Section 2.1. So chapter 2 takes a different direction. Now we're talking about what a function is. A function is a relation in which the first coordinate, namely the x coordinate, does not repeat. Given distinct points, of course. If they list the same point twice, that doesn't count. Domain is always the allowable x values, and range would be the allowable y values. So we're going to stick with this one definition all throughout this section, actually throughout this book. What's a domain? What's a function? A function is a relation in which the first coordinate does not repeat. So let's start with the first example. Determine whether the relation represents a function. State the domain and range of each relation. Okay, give me a second. Well, we start with the first. Again, we're going to determine if this is a function or not. So they're going to ask us whether a relation represents a function given points, given a map, given a graph, and given an equation. These are the four cases that we see. And I'm going to touch on all except the equation. We're going to leave until after we master graphing. So, looking at points, well, it's very simple. You look at the x coordinate, 1, 2, 3, 4, 5. The x values don't repeat. Function. This is a function. State the domain. Allowable x values. What are the x values? 1, 2, 3, 4, and 5. How about the range? What would be the range? Well, the range would be the y values. 2, 3, 5. That's it. Notice the y repeats, but for a function, it's only the first coordinate. The y's don't count. Not for a function. For something else later on. How about example B? Example B, I'm trying to determine if this is a function or not. 1, 2, 3, 4. 1, it repeats. But do you notice this point and that point are exactly the same? So somebody listed the same point twice. They're not distinct. So that doesn't count. This relation only consists of those 4 points. So since that is identical to this, it doesn't count. So in this case, we say, well, that's a function. Domain, allowable x values, 1, 2, 3, and 4. Range, that's an odd looking D. Range, allowable y values, that would be the 2, 3, 5, and 6. And that's pretty much it. Fairly simple. So we're going to be dealing with functions for a long time. How about this? Well, does the x value repeat? 1, 2, 1. It does repeat. Right there. And these are not the same points. So, not a function. What's the domain? Allowable x values, 1 and 2. What's the range? Y values, 2, 3, and 5. And that's pretty much it for this part. Given point, that's how we do it. Fairly simple. Given a map, well, you could really, a map and points are almost the same thing, because you could, if you wish, list those as, again, this is kind of the x, this is the y, so you could say A goes to E, B goes to L, C goes to D, and A goes to L. Basically, A, B, C, and A. So those, oh, that wasn't intended, I'm sorry. The intention was to make that, oops, I'm messing up everything. The intention was to make that a D. Again, I want an example of each. So this last part is really D. And when you look at this, you notice they don't repeat. As it wasn't a function, but now it is a function. And if I pick domain, that would be A, B, C, and D. The range will be where you go to. Well, we go to E, L, D, and L again, but they already listed that. You don't have to put those in order. If I look at E, I'll say 1 goes to 1. That's 1 coordinates, because, obviously here what you're doing, you're squaring. That doesn't have to. 2 squared, that goes to 4. 3, 9, and negative 3, 9. So here, if I look at this relation, 1, 2, 3, negative 3. Okay, not a problem. So this is a function. And domain, 1, 2, 3, and negative 3. And range would be 1, 4, and 9. So you could list those as coordinates, and you could do the same thing Euler notation for function. Instead of a y, Euler decided to use f of x. A big deal for us. So by saying evaluate the function for the given values of x, by saying f of x instead of y, all what you're saying that this is a function. Well, negative 2, if I put a negative 2 in for x, I will get y, or f of x, equal 2 into negative 2 plus 1 squared. Order of operations, that's negative 1 quantity squared, that's 1. And 2 times 1 is 2. If I take negative 1 and I put that in, that is 2 times negative 1 plus 1 squared, that's 2 times 0 squared, that is 0. If I put 0 right there, well, I don't have to write it out, right? 0 plus 1 is 1 squared, that's 1 times 2, that will be a 2. If I put a 1 for x, 1 plus 1 is 2, squared, that's 4. 4 times 2 is 8. And if I put in a 2 in there, 2 plus 1 is 3, squared is 9, 9 times 2 is 18. If I look at B, if I throw a negative 2 in there, I'll get, when x equals negative 2, I'll get 1 over negative 2 minus 2. Isn't that negative 1/4? 1 over negative 4? What if I was to put a negative 1 in there? So g of negative 1, or y, if you want to call it, 1 over negative 1 minus 2, that is negative 1/3. What if I put a 0 right there? Wouldn't the denominator be negative 2? How about if I put a 1? 1 minus 2 is negative 1, which is a negative 1. And what if I put a 2? Isn't that 1 over 0? That would be undefined. If I am to evaluate the next set of problem, well, f of x, again, it's a function, that's x squared minus 3. What do you think f of 0 mean? Well, if you really like, it's up to you. For starters, you could say x and x squared minus 3 and say, I'm going to test 0, I'm going to test 1, I'm going to test a, I'm going to test t, and I'm going to test a plus t. If I put a 0 right there, wouldn't that be 0 minus 3, which is negative 3? What if I put a 1 in there? F of 1, wouldn't that be 1 squared minus 3, which is negative 2? What if I put a? Well, isn't it just whatever x is, you put it right, oops, you put it right there. So isn't that a squared minus 3? How about f of t? Well, isn't that t squared minus 3? And the most crucial of them all, what is f of a plus t? The same as all of those. You're going to take the a plus t squared minus 3. And if you FOIL this, isn't that a squared plus 2at plus t squared minus 3? Again, that is really taking this and multiplying it by itself, or you FOIL if you have that memorized and you proceed. And what if I look at the function p? What is p of 0? Well, again, there is y equal. Put 0 in. That's where the 0 is going to go. If I take p of 0, well, wherever you see the blue part, that's where you put the 0. Isn't that 0 over 1, which is 0? I'm working sideways just so you can see it. You're supposed to work downwards. How about p of 1? Again, wherever you see the blue mark, you put a 1 in there. So every problem, this will change. Everything else will hold the same. That's 1/2. Done. You want to make it like that, you can. How about p of negative 1? Well, that is a 1 over 1 negative 1 plus 1. Isn't that negative 1 over 0? Undefined. And what is p of b? That is b over b plus 1. And that's my answer. Doesn't mean much. And what is p of h? That is h over h plus 1. Again, doesn't mean much. Wherever you see add. What do you suppose p of b plus h would mean? So again, there and there plus 1. That's going to be b plus h, b plus h plus 1. Identical to what we did. And that turns out to be b plus h over b plus h plus 1. Done. Okay, the next problems. Well, g of x, y equal, again, the varying part is right there. That's the only part that's going to change. So when I say, what's g of t plus 2? Well, that is replace x by t plus 2. And what would that be? T plus 2 minus 2 cancels out. And there it is. Done. And what is g of this massive mess? It doesn't matter. Something to get used to. A plus t plus c. That is, go to the right of the equal, and you're going to place and subtract the 2 whatever is in there. That's going to be on every problem for this specific function. So that's a plus t plus c, and that turns out to be a plus t plus c minus 2. Done. And what if I decided to look at a different y with a radical? So what? Same thing. If I take this with a radical and I want to evaluate these values, again, the only place I have to be concerned is right there. Every problem that uses that function f will have a square root, a quantity minus 1. So when I say, what is f of a plus h? Well, a plus h is the only value I'm going to change. There's a radical on every problem. There's a minus 1. And all what I have to do is put in a plus h, simplify if I can. In this case, that's what I get. That's fine. And what if I wanted to find f of this? Well, it doesn't matter. All of these problems are the same. For this case, I'm going to take a square root minus 1. Whatever this is, I'm going to put right there. And that will be the square root of a plus h minus k minus 1. It doesn't mean much, but it doesn't have to. Okay, I'll finish this on the next video.